Hello, and welcome to our discussion of measurements and calculations in chemistry. This is really a math review, and what everybody should do as they are studying their material is to read the section of the book that is entitled Measurements and Calculations in Chemistry. In the actual hard copy textbook, this is pages 1 through 26. In the ebook, it's the review section just right before chapter 1. So the point of this is to prepare you well for the chapters that will come a little bit later in the semester when we really have to do a lot of math. And we're going to review concepts that will serve you well in any branch of science. In science, what we do is we make observations, and a lot of our observations consist of measurements. And most measurements in science are quantitative in nature. So if you have a quantitative measurement, that consists of two pieces, a number and a unit. Both the number and the unit must be present for the measurement to be meaningful. Now, of course, there are lots of problems with standardization. In the United States, we use the English system. So we're using a Fahrenheit temperature scale and we're measuring length in inches and feet. But everywhere else in the world, they use the metric system. In science, the metric system reigns supreme, and the metric system is what underlies the so-called SI units that we're going to use in this class and in your other science classes. SI stands for Système International, and it's just the standardized scientific units that are used all over the world. So a lot of metric units will be familiar to you. I just want to go over a number of different measurements and the SI units for each of those measurements. So the first type of measurement that I would like to talk about is something very basic, length, measuring how long something is. The SI unit of length is the meter, which is abbreviated with a lowercase letter m. Now, you guys can probably visualize a meter stick. So you can imagine about how long a meter is. And if we imagine 1 meter, that consists of 100 centimeters. So look at this little prefix, centa. These little Greek prefixes are ways of scaling units up or down to change the size of the unit depending on kind of the size of your measurement. So in your book, there's a very nice table. Here's a screenshot of that table, table R-2. And this table describes all the prefixes that are used in the SI system. So here, the ones that I've kind of outlined on the top, these prefixes, exa, peta, tera, giga, mega, kilo, hecto, and deca, those are prefixes that scale a unit up. So a kilometer, for example, is larger than a meter. In fact, we have 1,000 meters in a kilometer. So the kilo prefix literally means 1,000 or 10 to the third. Another way of writing this is that we have 10 to the third meters in a kilometer. So that kilo prefix literally means 10 to the third. And you can stick that kilo prefix in front of any SI unit to scale it up. You also have quite a few prefixes that scale units down. And in chemistry, we use these prefixes quite a bit because we're generally talking about atoms and molecules, which are very small scale. So particularly when we're talking about length, we're using things like picometer or nanometer. So just going through some of these, centi is 10 to the 2, so that centi literally means 10 to the minus 2, rather. That centi literally means 10 to the minus 2. So another way of kind of writing this would be to say that 1 centimeter equals 10 to the minus 2 meters. That centi literally means 10 to the minus 2. And that's exactly the same thing as saying that there are 100 centimeters in a meter. Milli is 10 to the minus 3. So 1 millimeter is 10 to the minus 3 meters. And micrometer here is 10 to the minus 6. So you might use that one in biology because most bacteria have a diameter of around 1 micrometer, also known as 1 micron, and that's 10 to the minus 6 meters. So you can kind of see how you can scale a unit up or down. Another way of saying this is that there are 1 million micrometers in 1 meter. Okay, so you can say it either way. These mean exactly the same thing. So it's good to always have these prefixes at your disposal because you can put them in front of any SI unit to scale the unit up or to scale it down, depending on what you're talking about. Another measurement that's very common in all branches of science is mass. The technical definition of mass is the measure of the resistance of an object to a change in its state of motion. It's not the same as weight, even though they're often used interchangeably. It's mass and weight are not the same. Weight has to do with gravity. Weight is the force that a mass feels due to gravity. But mass is generally thought of as the amount of matter, and we would weigh out mass on a balance. The SI unit of mass is the gram, which is abbreviated with a lowercase letter g. And just like with the meter, you can use prefixes to scale it up or down. For example, 1 milligram is 10 to the minus 3 grams. Another way of saying that is 1,000 milligrams is equal to 1 gram. So milligrams are smaller than a gram, so there are many of them in a gram. You can scale it up as well. 1 kilogram equals 1,000 grams, or 10 to the third grams. Okay, so kilo literally means 10 to the third. So you can use any of those prefixes to scale the gram up or down. And you should be able to interconvert between the units with different prefixes. Another physical quantity that we measure in science is time, particularly when we're measuring reaction rates, for example. The SI unit of time is the second, which is abbreviated with a lowercase letter s, or sometimes you'll see it with SEC, but generally just lowercase s is enough. And you can scale the second up or down. Sometimes people say nanosecond. So 1 nanosecond is equal to 10 to the minus 9 seconds. So it's a very, very, very small fraction of a second, for example. A compound kind of measurement is volume. Volume is not a fundamental measurement, but its units are derived from length, as you probably know from your prior schooling. So the class example is, of course, the cube. So now you can see my horrible drawing of a cube. So let's say we have a cube, and that cube has length, width, and height all the same. 1 centimeter length, 1 centimeter width, 1 centimeter height. What is the volume of the cube? Well, you just do length times width times height to get 1 centimeter times 1 centimeter times 1 centimeter, which equals, of course, 1 centimeter cubed. 1 centimeter cubed. Now, you might have heard of 1 centimeter cubed before. In a medical context, it's also often abbreviated as a cc. A cc just means a centimeter cubed, or a cubic centimeter. And 1 cc is also equal to 1 milliliter. So for volume, we have two SI units. We have centimeter cubed or meter cubed and milliliter. In general, we measure the volume of solids in centimeters or meters cubed, and we measure the volume of liquids in milliliters or liters. Just to show you the relationship of 1,000 milliliters is equal to 1 liter. And that would be also equivalent to saying 1,000 centimeters cubed or cubic centimeters. A liter is about equal to a quart. So if you think about a quart of milk, that is about the idea of how much a liter is, or a liter bottle of soda. You will notice in the problems in the book, a measurement called density, which is really another compound measurement of mass over volume. And the density measurement literally tells you how much matter you have in a given unit of volume. So the units of density would be grams, which is the SI unit of mass, over milliliters, which is the SI unit of volume. Or you could also express it as grams per cubic centimeter, or grams per liter, or gram per any unit of volume, depending on how you want to scale up the unit. Okay, so I will stop there for just a moment, and in the subsequent videos, I'll talk about temperature.